Chapter 8 Weight and Balance Control, Helicopter Introduction. Weight and balance considerations of a helicopter are similar to those of an airplane, except they are far more critical, and the center of gravity (CG) range is much more limited. Figures 8:1 and 8:2, the engineers who design a helicopter determine the amount of cyclic control authority that is available, and establish both the longitudinal and lateral CG envelopes that allow the pilot to load the helicopter so there is sufficient cyclic control for all flight conditions. If the CG is ahead of the forward limit, the helicopter tilts and the rotor disc has a forward pull. To counteract this and maintain a stationary position, rearward cyclic stick displacement would be required. If the CG is too far forward, there may not be enough available cyclic authority to allow the helicopter to flare during landing, and it consequently requires an excessive landing distance. If the CG is aft of the allowable limits, the helicopter flies with a tailo attitude and may need more forward cyclic stick displacement than is available to maintain a hover in a no-wind condition. There might not be enough cyclic travel to prevent the tail boom from striking the ground. If gusty winds should cause the helicopter to pitch up during high-speed FLGHT, there might not be enough forward cyclic control to safely lower the nose. Helicopters are approved for a specified maximum gross weight, but it is not safe to operate them at this weight under some conditions. A high-density altitude decreases the safe maximum weight as it affects the hovering, takeoff, climb, auto-rotation, and landing performance. The fuel tanks on some helicopters are behind the CG, causing it to shift forward as fuel is used. Under some flight conditions, the balance may shift enough that there is not sufficient cyclic authority to flare for landing. For these helicopters, the loaded CG should be computed for both takeoff and landing weights. Lateral balance of an airplane is usually of little concern and is not normally calculated. Some helicopters, especially those equipped for hoist operations, are sensitive to the lateral position of the CG, and their pilot's operating handbook/rotorcraft flight manual, PO/RFM, include both longitudinal and lateral CG envelopes, as well as information on the maximum permissible hoist load. Figure 8.3 is an example of such CG envelopes. Determining the loaded CG of a helicopter. The empty weight and empty weight center of gravity, EWCG, of a helicopter are determined in the same way as for an airplane. See Chapter 5, Single-Engine Aircraft Weight and Balance Computations. The weights recorded on the scales supporting the helicopter are added and their distances from the datum are used to compute the moments at each weighing point. The total moment is divided by the total weight to determine the location of the CG in inches from the datum. The datum of some helicopters is located at the center of the rotor mast, but since this causes some arms to be positive, behind the datum, and others negative, ahead of the datum, most modern helicopters have the datum located ahead of the aircraft, as do most modern airplanes. When the datum is ahead of the aircraft, all longitudinal arms are positive. The lateral CG is determined in the same way as the longitudinal CG, except the distances between the scales and butt line 0, BL0, are used as the arms. Arms to the right of BL0 are positive and those to the left are negative. The butt line 0, or sometimes referred to as the buttock, is a line through the symmetrical center of an aircraft from nose to tail. It serves as the datum for measuring the arms used to find the lateral CG. Lateral moments that cause the aircraft to roll clockwise are positive, plus, and those that cause it to roll counterclockwise are negative. To determine whether or not a helicopter is within both longitudinal and lateral weight and balance limits, construct a table like the one in Figure 8.4, with the following data specific to the aircraft: empty weight, 1,545 pounds EWCG, 101.4 inches aft of the datum. Lateral balance, arm 0.2 inches right of BL0. Maximum allowable gross weight, 2,250 pounds. Pilot, 200 pounds at 64 inches aft of datum and 13.5 inches right of BL0. Passenger, 170 pounds at 64 inches aft of datum and minus 13.5 and left of BL0. Fuel, 48 gallons, 288 pounds at 96 inches aft of datum and minus 8.4 inches left of BL0. Check the helicopter CG envelopes in Figure 8.3 to determine whether or not the CG is within limits both longitudinally and laterally. In the longitudinal CG envelope, draw a line vertically upward from the CG of 94.4 inches aft of datum and a horizontal line from the weight of 2,203 pounds gross weight. These lines cross within the approved area. In the lateral offset moment envelope, draw a line vertically upward from the minus 1,705 pounds in point, on the left side of the horizontal axis, and a line horizontally from 2,203 pounds on the gross weight index. These lines cross within the envelope, showing the lateral balance is also within limits. Effects of offloading passengers and using fuel. Consider the helicopter in Figure 8.4. The first leg of the flight consumes 26 gallons of fuel, and at the end of this leg, the passenger deplanes. Is the helicopter still within allowable CG limits for takeoff? To find out, make a new chart like the one in Figure 8.5 to show the new loading conditions of the helicopter at the beginning of the second leg of the flight under these conditions. According to the helicopter CG envelopes in Figure 8.3, both the longitudinal CG and the lateral offset moment fall outside of the approved area of the envelope. The aircraft longitudinal CG is too far aft and the potential for excessive taillow attitudes is very high. Under these conditions, it is possible that there will not be enough forward cyclic authority to maintain level flight. The helicopter's lateral offset moment is too far right and may lead to control issues, as well as an increased hazard of dynamic rollover. One possible option to bring the aircraft loading conditions within the approved envelope is to load either ballast or a passenger, as computed in Figure 8.6 and plotted in Figure 8.3.